All right, assignment 6-1, slope fields. Find the slopes given by that differential equation using those points. So we're going to plug in the x and y and just get the answer. So plug in 0 for x, 0 for y. 0 divided by anything. This answer is 0. Plug in 1 and 1, and you get the answer -1. Plug in -2 and 4. That's positive 4 over 2. That's 2. For D, plug in 4 and -2. You get 16 divided by -4. -3 and -3 is going to be a fraction. That's 9 over -5. 5 and 12, I think that's going to be a fraction. 144 over 3. No, 25 over 5 squared. 25 over 10. You could also write it as what? 5 over 2. For the differential equations in problem 1, why are there no slopes when y equals 2? Because when y equals 2 is undefined. The slope field for y prime equals x divided by y is shown to the right. I'm going to switch colors here. And it says plot the points on the slope field. And can you draw the solution of a differential equation? So at 1, 2, could you draw that solution? What's the next point? At 3, 1, I don't know if I have enough colors to get through. I can try. At 3, 1, so think of like the direction it's going, and think of the direction now here. It's going to be a hole, so it's just that little part right there. Change colors again. What's the next one? 0, 3. I think there's a tearaway, right, that you can do it. I wasn't even thinking it. So there is. So maybe I should have just answered on here. So do your work here, and then use this, right, to support. I'll just continue it on here. Where am I at? 0, 3. That's the turning point. So it's good to know where the horizontal tangent is, because that's where it turns. So that's where so that's a turning point right there. 0, -2. And then, what color do I have left? Green. It's -2, -1. Make sure there's a hole right there. So follow the current, the way the river is flowing, and you follow it and draw your curve on that. And then it says solve the differential equation. So I'm going to do that. It says plot a solution curve for each one, which I did. And what would a solution curve containing 2, 2 look like? So if you did 2, 2, it would look like a half line. So 2, 2 is right here, 2, 2, and it's right on a line. But as you draw it, it would stop right there. I'll solve that differential equation. I'm going to do that on a separate piece of paper right here. So to solve this, it's dy by dx. Multiply both sides by dx and by y. And then I'm going to integrate both sides. I'm going to multiply by 2. I'm going to change this out to a simpler constant. And then if I solve it generically, it would just be positive and negative the square root of x squared plus a constant. All right, 4. Let's go back here. And again, you can answer it on the next page. You can answer it. So we have a differential equation, just that the slope is equal to whatever the y value is, and then graph the particular solutions that are passing through these points. All right, so first of all, draw the slope field. So when it's just the y coordinate, we can just go row by row. The first row is 0, then 1, then 2, then 3, negative 1, negative 2, negative 3. Those are the y values, and those are the slopes I'm going to use. So for 0, the slope is a horizontal line. It's defined. It's not empty, but they're horizontal lines, which means those are turning points. For 1, it's going to be a slope of 1 going across, up 1 and to the right 1. For 2, it's up 2 and to the right 1, so it means it's a little steeper. And then 3, go 1, 2, 3, and it's even steeper. Negative 1, down 1 and to the right 1. Negative 2, down 2 into the right 1, so it's a steeper going down. And then negative 3, even steeper, pointing down. And then the question is, can you draw the solution passing through 0, 1? So find 0, 1, and then follow the flow of what's happening. So it's flowing. In this one, it's flowing, and then it flattens out. So you can see that it looks like an exponential. At 0, negative 1, follow the flow going one way, and then the flow the other way. And it's also an exponential. And then it says solve it. So I'm just going to do that right here. So I'm going to multiply by dx and then divide by y. This is a logarithm. And then when I solve for y, it'll be e to the x times e to the c. When you remove the bars, it'll be plus or minus. And then just replace that with an easy constant. Now, if I want to find the specific ones, so like for 0, 1, if I plug in 0 for x and 1 for y, e to the 0 is 1, so c2 times 1 is equal to 1, so it's 1. So it's just y equals e to the x. And that's definitely what it looks like, y equals e to the x. And then for 0, negative 1, if you plug in 0 and negative 1, then this would equal negative 1. So it'd just be y equals negative e to the x. So the blue is e to the x, and this pink is y equals negative e to the x. Number 5, draw a slope field. I'm going to go here to draw it. And it's x divided by 2. So because it's x divided by 2, only the x value, I can actually go by columns. So if I plug in 0, the slope is 0. If I plug in negative 2, the slope is negative 1. If I plug in negative 1, the slope is negative 1/2. Positive 1 would be positive a half, then positive 2 divided by 2 is 1. So each one, so negative 1, negative a half, zero, positive a half, and then positive 1. And then in part B it says, draw the solution passing through negative 1, positive 1. So you can see what's happening there. You can see what's happening here. And again, I'm very aware that here is 0, so it's going to turn there where there's a horizontal tangent or slope. In part C, it says solve for it. So I'm going to take this, multiply by dx. And then integrate. This is going to be x squared divided by, so it's going to be 1/4 x quarter. So add 1 and divide. That's the general solution. And then find the particular one through negative 1, positive 1. So plug in negative 1 for x, positive 1 for y. This is just 1/4. Subtract $1, take away a quarter. Of course, it's 3/4. And then you have your answer. Number 6, I'm right here. For the derivative is 1 over 2y. So if it's only the y values, I go by rows. So at 0 is undefined. At 1, the answer is 1/2. And at 2, the answer is 1/4. At negative 1, it's negative a half. And at negative 2, it's negative 1/4. Now I'm going to draw the slopes. This one's even flatter. It's negative a half. And this one's even flatter. And then it says draw the solution through negative 1, 2, right? For negative 1, 1. And then you can see what's happening here, and then you can see what's happening here. It almost looks like a square root. So you can see that in terms of it. If I solve the diffie-q, I'll separate the variables. So I'm going to multiply by 2y and multiply by dx. Integrate both sides. So this is y squared is equal to x plus c. And it is a square root. You can see it. It could be positive or negative. If I plug in the point, which is negative 1, 1, and solve it, you can see that c is equal to 2. So I come back here and I write down y equals, because the y value is positive, I use the positive one. And we just found c to be 2. And it's nice to know your functions to see what the curve looks like, and you can confirm that it matches. All right, number 7. Y prime y squared equals 1. So to get y prime by itself, I'm going to divide by y squared. So it's 1 over y squared. Again, I can go, because it's the y's, I can go row by row. So if I plug in 0, it is undefined. If I plug in 1, the answer is 1. And if I plug in 2, it's 1/4. -1 will give the same answer. And -2 will give the same answer as above. So these will marry each other. So we have 1. And then 1/4 is like up 1 over 4. And you can see me count. I counted up 1, I went over 4, and then I just mirror it across. And then it says, oh, -1, 1 again. And then what does it do with that? And then solve the diffie for -1, 1. So dy by dx multiply by dx and multiply by y squared. Integrate it. Multiply by 3. We'll take that and make it a simpler constant. It's a good time to plug in -1, 1. So I plug in +1 for y and -1 for x. Solve it. This is -3, so add 3. That's 4. So if I come back here, to undo this is the cube root, and it's 3x plus 4. Number 8. (2x, y minus 1). This is going to be the toughest one. Because it requires both, I have to think my way through this. I can't just go row by row or column by column. But one thing I know is when x is 0, the slope is 0. And when y is 1, the slope is 0. So it's good to take care of the horizontal tangents. And now we just kind of got to go one by one to see if I see anything that makes sense after that. So like here, this is 1, 0. So that's 2 times -1, so that's -2. 2, 0. That's -4. -1, 0. That's going to be positive. So it's going to mirror these but as a positive slope. 2, 2 is 4 times 1. 1, 2 is 2 times 1. And then these slopes, when I put in -1, 2, it'll mirror the other way. So there's a negative slope. So if I find these slopes, these are the same but negative on the other side. 2 and -1. And this one will go the other way. 1 and 2. -2 and 2. Alright, so once we have those slopes in, is it -1, 1 again? Oh, it says use the origin instead of -1, 1. So we're going to start here at the origin instead. You can see what direction it's curving. It looks like a parabola. When I do it, we might be. Let's see. So we have dy by dx. And I'm going to separate the variables. So I'm going to divide by y minus 1 and multiply by dx and integrate this. So this is going to be a logarithm. And this is x squared plus c. So we have y minus 1. And then e to the x squared. I write this as e to the c instead of adding. And then when I remove the bars, I can replace that whole constant. And then add 1 to the other side. So there it is. Then through the origin, I would plug in 0 for x and 0 for y. 0, e to the 0 is 1. So if I solve this, c2 is equal to negative 1. So I'm going to write down y equals negative 1, or just negative, e to the x squared plus 1. So not a parabola, though it does have an x squared in there. It has like a reflection in there. That's what happened. So think of negative e to the x and then reflected and so on. But there you go. Interesting, right? Number 9. Oh, number 9's on this side. All right. So the slope at the right, field at the right, matches one of these. Which of the following could be the equation for that? So I see a turning point here. I see it curving down to the right, and I see it going up to the left. So I feel like it's a cubic. So if you get y to solve, and if you solve this one, it'd be negative 1/3 x cubed plus 2. And it's a negative x cubed, which means it goes down to the right and up to the left. Knowing that, the answer is A. It's not a circle. It's not a hyperbola. It's not a rational. Like the curves don't match. And same thing here. So this is the one that matches. How about the other direction? So you have a differential equation. Which one could match or not match? So I notice right away that when y equals 0, the answer is 0. So A and C must be wrong because it's undefined and not. 0, 0. Oh, wait a second. 0, 0. This one's off because it would be undefined. And then, so we have 3 that are left. So 0 take away 0, 0 take away 0, 0, 0. Fair enough. Then I would pick a point like here, 1, 1. So positive 1 should give you a positive answer. So like 1 take away 1, that's 0. And 1 take away 1 is 0. So the only one that's left that could match it is this one. We're at 1, 1. 1 times 1. That slope looks like it's 1, so it matches. So I find where the 0 slopes are, and then I pick like an easy positive 1 slope and plug it in to see if it matches. And then cross out the ones that don't. Number 11. So I'm going to take the derivative of this. The derivative rule for sine is cosine, and it has a hook of 2. And then the second derivative is negative sine, and again it has a hook of 2. So that makes it negative 4 sine 2x. And then I go to the question that talks about x cubed y double prime equals 4x cubed y. And then I substitute in. So y double prime is negative 4 sine 2x, and then y is sine 2x. And the question is, are these the same? And one is negative and one is positive. They're not the same, so it's not a solution. Let's look at number 12. Y equals e to the 2x. So the first derivative is e to the 2x times 2, and the second derivative is 2e to the 2x times 2, which is 4e to the 2x. So there's step number 1. So if I look at what's given, remember x cubed, the second derivative, 4x cubed y, I'm going to substitute in. So the second derivative is 4e to the 2x. Y is e to the 2x. And now look carefully, look carefully, look carefully. They're exactly the same. It is a solution. Because they match. Number 13. Without using a calculator, darn it, use Euler's method with step size of 0.1 to approximate f at 0.3. This is going to require a chart. X and y, the derivative, and then the change in y is the derivative times the change in x. So, here we go. So the first point they start off with is 0, 3. The derivative is x plus y. So 0 plus 3 is 3. And then to find the change in y, we take the derivative times the change in x. And in the question, the change in x is 0.1. So 3 times 0.1, which is 0.3. So now, if it's 0.1, this is 0.1. We take this answer and add it to y. So now it's 3.3. And now I recalculate. So I'm going to add the x and the y. I take 3.4 times 0.1. Move the decimal. What do you get? 0.34. This is now 0.2 because I just keep adding. This is 0.3. It's really changing the y value. So we take 0.34 and add it to 3.3. And I get 3.64. And now I do the work for the derivative. Add these together, I get 3.84. One more time, 3.84 times 0.1. Move the decimal. 0.384. And you get your answer. So we're going to add these together. That's 3. So it's a 4. 8 plus 4 is 12, and 1 more. So that makes it 4. So it's 4.024, right? That's it. That's called Euler's method to find a value. And the answer is 4.024. It takes practice. It's good to organize with the chart. Number 14. Euler's method again. So y at 0 equals 2. The derivative is 2x minus 3y. And each step size is 1/2, or 0.5. All right. So we're going to start with 0, 2, and then we're going to plug in. So that's 2 times 0, take away 3 times 2. So I get negative 6. And then I take negative 6 times 1/2, and I get negative 3. So again, this is going by halves. Negative 3 and 2 now make negative 1. So 1/2 times 2 is 1. Negative 3 times negative 1 is 3. So it's 1 plus 3, and that's 4. And I start with 4 times 1/2. I get 2. Now my goal is to get to, just to use 3 steps. So I've done 2 steps. So 1/2 and 1/2 is 1. Take your answer, add it to negative 1, so now it's 1, 1. And then plug it into the formula. So that's 2 take away 3. Sorry, this is step 1, step 2, and then we'll get our answer at the end. So it's negative 1 times 1/2, which is negative 1/2. So 1 and 1/2, add them together, and you get the answer. Number 15. Again, using Euler's method. Oh, using a calculator now. And the steps are, it says use 4 steps or to approximate 0.8. So if I start at 1 and I use 4 steps, does it tell me what my step value is? No. If I go 1 divided by 0.8 times 4 steps. If I go 1 take away 0.8, if we're going down in value, right? So 0.8 take away 1 divided by 4. That's what I would do in my calculator to find the steps. Let's see if I'm right. 0.8 take away 1 divided by 4. And I get negative 0.05. Good. So sometimes you got to figure out the steps. So I subtract and divide by how many steps to figure out what each step would be. In the question it says 1, 2 to begin with. So subtract 0.05 to get the next one. But anyways, we're going to need this. That's this right here. Negative 0.05. And you're going to use your calculator to calculate. So plug in e to the exponent 1 times 2. So e to the 2 and approximate it. So it's about 7.389. And then take that answer and multiply it by negative 0.05, and you get the answer negative 0.369. Again with the calculator. Then I'm going to subtract 0.05. I'm going to take that answer in this, so 2 take away 0.369. And then e, and I multiply these together, e to that, and then use your calculator. So 4.707, and then take 4.07 times negative 0.05. Yes, I'm looking at the answer key to try to be efficient about it, and you get the answer. Subtract 0.05. Take this answer and subtract it. So 1.631, subtract this. You get 1.395. Then go e to the exponent and multiply these together, and you get 3.510. Then take 3.510 times negative 0.05. You get negative 0.1676. We're going to do it again. Subtract. So now we're almost there, 0.85. Take negative 0.176 in this and subtract them, and you get 1.220. E, and you multiply these together, e to that exponent, and you get 2.820. So take 2.820 times negative 0.05. We're almost there. This is what I wanted to get to. Take the answer, 1.220, subtract. It's now 1.078. And you have your answer. All right. That was tedious. Number 16. Write it down. It's actually a really easy question, but it looks complicated. So what should this remind you of is the original definition of a derivative. So the original definition of a derivative would have been this. The limit as h approaches 0, right? And so this is just the function you're taking the derivative of. So this is what you'd be taking the derivative of. So I understand what's happening here. But this second part, after the subtract sign, you're just asked to take the derivative of that. That's your answer. So the derivative of t is 1, and the square root of t is 1/2 t to the negative 1/2, and you have your answer. Oh, plus c? Oh, that's the derivative. So if you integrate it, then that's the answer. Oh, even better. So if this is the derivative, and you're asked to find f of t, you would integrate this. Well, if you integrate a derivative, then the function is your answer. And you just need to go plus c at the end for your answer. Ha. But if it was like, what is this? The answer would have been 1 plus 1/2 t to the negative, recognizing that's the function of what you're working with. All right, number 17. For each of the following, give a reason why each function is not differentiable for those x values. Find the values where each of the functions not differentiable. So for this one, when you make it equal to 0 and you solve it, both at positive and negative 3, it has to do with a corner. And to write it in a better way, from the left and from the right, these derivatives don't agree. There's a corner there, right? And the derivative doesn't exist at a corner or a sharp turn. And you would say the same thing about positive 3, that from the left and from the right, the derivatives don't agree. Number 18, that's a greatest integer function. So what creates an integer here? Because of the times 2, it's every half step. So because of this, every half creates an integer answer. So every half value of x, there's a jump. The derivative doesn't exist where it's undefined. So at x equals 0 and -1, whether it's a whole or an asymptote, it does not exist at either one because it doesn't exist at a discontinuity. So at 0, it does remove, but it's a whole. This is a vertical asymptote. If it's a discontinuity, the limit can exist at a whole, but not a derivative. Number 20. So at x equals 0, because of the 1/3, or is it everywhere? It feels like it's everywhere. Oh, let's take the derivative of it. It's a good idea. So where can you not take the derivative? And if you write this algebra friendly, what you see is that at x equals 0, there's a vertical tangent. So it's not undefined there or nothing, but there's a vertical tangent there. That makes the derivative not exist. 21. So first of all, if I plug in 1, the answer is 3. If I plug in 1, I get 4. It's still 3. So it's continuous. Take the derivative. And if I take the derivatives, do they match? So this is always differentiable. So I plug 1 into the top and 1 into the bottom. They match. Take the derivative, plug 1 into the top. There's no variables. The answer is always 2. Plug 1 into the bottom, the answer is 2. So both the continuity and the differentiability, they match, so it's good. 22. If a particle moves along y equals x to the 2/3, and dx by dt equals 3. Find all for all x. Find the following. So if I take the derivative with respect to time, take the derivative, then it needs a dx by dt. I'm going to plug in when x is -1. I'm going to plug -1 in here. And dx by dt is 3. And so -1 to a cube root would be a -1 answer. So it's -2/3 times 3, so that answer is -2. B. All right, when x equals 8, so I did already the work. The cube root of 8 is 2. The negative exponent makes it the reciprocal. The 3's, the 2's cross out. The answer is 1. C. The limit as x approaches infinity of dy by dt. If it was calculus friendly, I think you'd see it better. So as this goes to infinity, this will always stay 2. This will get to be a very large number. So when the power term is more powerful in the bottom, this always approaches as the right-hand behavior is going to 0. D, from the left at 0, So as it approaches from the left of 0, like negative values, this is going to negative infinity. So if I put in negative 1 over 100, negative 1 over a billion, it's going to be a negative answer, but the reciprocal is going to make it very, very, very large. So it's a negative huge number. So that's why it's negative infinity. 23. Use a tangent line to graph y equals x to the 2/3 to approximate 8.1. So a tangent line, I need x, y, and the slope. So I'm going to use 8. And if I plug in 8, the cube root of 8 is 2, and 2 squared is 4. And then I'm going to find the derivative there. That's 2/3 x to the negative 1/3. I'm going to plug that in. And the cube root of 8 is 2, but the negative exponent makes it the reciprocal. And then if you multiply it out, the 2's cross out, so the slope is 1/3. So the tangent line is 1/3 x minus 8 plus 4. And then use that to approximate 8.1. So that's 0.1. Another way to say that is 1 over 10. So this answer is 4 and 1 over 30. As an approximation. Why could a tangent line for that at x equals 0 not be used? At x equals 0, if you look at the derivative with the negative exponent, at 0 it's undefined. All right, without using a calculator, do a bunch of stuff. So, can we analyze and graph this together? Let's try. Step 1 is to factor this. So I factor out a 2x and x. This is a difference of squares. This is a difference of squares. And then notice the x's do cross out, so there's a hole in the function. So the domain x cannot equal a 0 and positive and negative 2. That's a hole. Those are vertical asymptotes. Intercepts. If I look at the top, we have x-intercepts at negative and positive 1. We have a y-intercept. We also have a hole that's an intercept. 0, 0. Or not 0, 0. If I plug in 0, where is the hole? At 1/2. So if you plug in 0 here, you end up with 1/2 if you reduce it down. So 0 and 1/2. Positive and negative 1 are the intercepts. The y-intercept doesn't exist. There's a hole there on the y-axis. That's what this is. The derivative, to know where it's increasing and decreasing. Oh, don't even do like the calculus part. So at positive 2 and at negative 2, and then 1/2, we have a horizontal asymptote, the power terms, at y equals 2. And so then we have the picture of that. Some pre-calculus work. 25. A region in quadrant 1 is enclosed by the graphs y equals x, y equals cosine x, and the y-axis. So it's this right here. So you have the y-axis, y equals cosine x, that starts at the top of the wave, and then y equals x, all that, and then shaded in. Use a calculator, and what are we going to do? Revolution. So there's going to be circles. So if I'm going to revolve that about the x-axis, that's 2 circles. So we're going to go from 0. We need to know this. So with your calculator, you're going to go cosine x equals x, and then use your calculator to see what that value is. That's 0.739. So solve it with your calculator, and you get 0.739. Let me just make sure you know how to do that. Menu, algebra solve. X equals cosine x, comma x, and then we're going to go control equals, and we're going to do a domain restriction that goes from 0 to pi over 2. So then I only want that answer. So if I do the restriction like that, if you don't do a restriction at the end, it'll be a generic answer. There's an infinite number of solutions to it. So we have to solve it and know. Actually, it would only be 1 even without it, I think, because of the way the line's going. Anyways, 0.739. There it is. So it goes from 0 to 0.739, and there's 2 circles, the big radius and the small radius. So the big radius is the curve down to the bottom. The small radius is the line down to the bottom. And then use your calculator, and the answer is 1.520. We're going to do it again. This time, we're going to revolve it about y equals -1. That's down here. Same thing, we got 2. So the big radius is the from here to the curve. So cosine, subtract -1, or cosine plus 1. The small one goes from the line down here, so that's x subtract -1, or x plus 1. And then use your calculator, and you get the answer 4.037. About the y-axis, now when we do this with the y-axis, we're going to use our cylinder, our shell method. So the x-coordinate, so it's 2 pi. The x-coordinate is going to be the radius. And then we're going to go right top subtract bottom for the height. So that's cosine subtract x for the height. So we have the x-coordinate, and then the height of it is top subtract bottom. That answer is about 0.643. And you use your calculator. D about x equals negative 1. So we're still going to use the shell method. This time the radius is going to be the x subtract negative 1, or x plus 1. So right subtract left. When you subtract a negative, it's adding. We're still going to go top subtract bottom, so the height didn't change. And now calculate with this, and you get the answer, 3.160. All right, 26. We're going to integrate from 0 to 2. The derivative of this is negative 2, what it was and what it became. So that's negative a half ln 5 minus 2t from 0 to 2, and then plug in. So if I plug in 2, I get ln 1. If I plug in 0, I get ln 5. Ln 1 is 0. So the answer is a negative times a negative, positive 1/2 ln 5. Or ln in the square root of 5, if you want to be fancy. That's 20, 26, 27. From 2 to 3, this is going to require long division because the power terms match. So we're going to divide, that's 1. When you subtract a negative, you're adding. So we're integrating from 2 to 3. We have the answer 1. And then the remainder is 2 over y minus 1. So when I integrate 1, that's y. When I integrate this, it's ln y minus 1, but it needs a 2 in front. And it's from 2 to 3. Plug in 3. And if you want, you can square that. Doesn't matter. 2 ln 2. Plug in 2. 2 ln 1. Now ln 1 is 0. So 3 take away 2 is 1. And that leaves me with 2 ln 2. Another way to write that would be ln 4, because that 2 could be squared. And you have the answer. 28. Integrate. The integration of x cubed plus 10 is 3x squared, so it needs a 1/3 plus c. Don't forget the bars. 29. So remember, there's not an integration for logarithms, so that means I'm going to write it as 1 over u, ln u to the negative 3. So the derivative of ln u is there, that's the hook. So then I just add 1 to the exponent and divide. Uh, 30. The derivative of 2x is 2, so I need a 1/2. So it starts with 1/2, copy, and then it needs to divide by ln 5. So another way to write this would be 5 to the 2x and then 2 ln 5, the 1/2 in written like that. Plus c. Thank you. 31. All right, don't be fooled. 5 squared is 25, so this is 25x plus c. 32. Sorry, I laughed at that. Sketch a graph of a function that has the following. Okay, it's continuous. Negative 2 and f at 0 is 0. F prime at 0 is undefined. The derivative, so if I did a number line, is greater when x is less than negative 1. and greater than 0. Between -1 and 0, it's this way. For a second derivative, so when it's less than 0, it's negative. When it's greater than 0, so it's concave up and concave down. So first of all, it's increasing up to -1. And it's increasing with a frown. And it continues to frown to 0. At -1 is a maximum, and at 0 is a minimum. After 0, it smiles. And so we have this, and we have this. That creates a cusp, so the derivative doesn't exist there. And there's the picture. 33. 2 left. Find the equation of a tangent line. At 1, 2. Step number 1, we have x and y. I need to find the slope. So this is 2x. This is the product rule. So 2x, the first, times the derivative of the second, plus the second times the derivative of the first, needs a y prime. This is 2y, needs a y prime, and the derivative of 3 is 0. If it has y primes, they're going to be put together. Subtract. If it doesn't have a y prime, it's going to the other side. So I'm going to subtract 2x and subtract 3y. And then I'm going to factor out a y prime and divide. At this step, I'm going to plug in 1 and 2, this point, to find the slope. It's -2, that's -6, that's 3, and 4. I get -8, I get 8. I hope that's right. It is. So then put it all together. So x is 1, y is 2, the slope is 8. So it's y equals 8, x minus 1 plus 2. Hey, we got there. 34, last one. Just over an hour. It's okay. A radioactive element has a half-life of 1,000 years. So there's the setup. It's half-life, 1,000 years. Use your calculator. Solve this. And K, when using your calculator to solve, is -0.0007. Then how much of 200 grams? So 200 is C. We just found K. Will remain after 750 years. So then plug in 750. Use your calculator again. I'm sure you'll trust me. 118.921 grams would be left. Awesome. Mr. G Math over and out. I'm really proud of you that you did your work today. Till next time.